For the last lesson of Chapter 3, we're going to be applying the Pythagorean Theorem. So first we'll do a real-world application, apply it, then we're going to find distance on the coordinate plane, then we'll be identifying right triangles then. First, our real-world application. Amy is making a brochure for an HD TV. The screen is 48 inches wide and 20 inches high. So what diagonal length should she use for the brochure? So if we're using this here, let's see here, this is our HD TV with the length of 48 and a height of 20. We know that rectangles you can always cut in half, and that's how we're going to solve this, because if we cut this in half, we now have a 90-degree triangle. See, this is a 90-degree right here. Here's short side A, long side B. So whenever you get these kind of problems and you have a rectangle like this or a TV or whatever you have, cut that in half, find a triangle, and now we can solve for the long side from corner to corner. So what is C? We need to find C squared, right? All right, so we have 20 squared plus 48 squared equals C squared. Let's write that over here. All right, so 20 squared, what is that? 20 times 20, that gives us 400. 400 plus 48 squared is 2304, and that equals C squared. 400 plus 2304, that's 2704, and that equals C squared. So if we square root both sides of this equation, we'll be able to find that C. Take the square root of C squared, that's C. 2704, the square root of that would be 52. So it's a 52-inch TV, because they always measure from diagonal to diagonal when they do TVs. Let's solve these ones then. We need to find distances between the points to the nearest tenth. It's asking us to find the distance between J and K. So for J and K, we can create a triangle here. It's 1, 2, 3 spaces down, 1, 2, 3, 4 spaces across. So now we can draw a diagonal line between J and K, which is going to be our distance here. So this would be a length of 3 down, a length of 4 across, and then this would be our C. So we'll do A squared plus B squared equals C squared. So it'd be 3 squared plus 4 squared equals C squared. 3 squared is 9. Then we'd add 4 squared, which is 16. So that equals C squared. And then 9 plus 16 is 25. So that equals C squared. If we square root both sides, we'd be left with C over here, and then 5 over here, because the square root of 25 is 5. So C equals 5. So distance between J and K is 5. Here we have L and M. So this diagonal line L and M, it's 1 across to the side, and it's 3 up. So it'd be 1 squared plus short side 3 squared equals the long side C squared. So 1 squared is 1, 3 squared is 9, equals C squared. So 1 plus 9 is 10 equals C squared. Then we square root both sides. Square root of 10 would be 3.16. So C equals 3.16. So 3.16, let's write this over here. That would be the length between L and M, this length right here. Here we actually can identify right triangles. And remember what I said before, that only right triangles follow this Pythagorean theorem. All other triangles would be a false statement. So if you do A squared plus B squared equals C squared for a triangle that's not a right triangle, it would be off. So what we can do is we can take these 3 legs of the triangle and say whether it is a right triangle or not. So if you need to draw a triangle for your reference, if you can't really think abstractly, you can do that. That's okay. So here's our triangle. So this side we can make 7. This is another short side, so 24. And then the long side over here would be 25. So it does a squared plus b squared equals c squared. So it does 7 squared plus 24 squared equal 25 squared. Let's find out. 7 squared is 49. 24 squared is 576. And then what is 25 squared? That's 625. So 576 plus 49, that's 625. So you're going to see here that we have 625 equals 625. So therefore, a squared plus b squared does equal c squared. So this is, yes, a right triangle. How about this one now? We have 5, 8, and 12. So if you need to draw that triangle, that's just fine. We would have 5 for the short side, 8 for the other short side, and then 12 for the long side. So 5 squared plus 8 squared equals long side 12 squared. So 5 squared is 25. 8 squared is 64. And does that equal 12 squared, which is 144? Well, 25 plus 64 would be 89. And we're going to see here that 89 does not equal 144. So a squared plus b squared does not equal c squared. So this would not be a right triangle. Even though I drew it like that, it is not a right triangle. So you would say not a right triangle.